Okay. Okay. All right. So welcome to this edition. We are going to look at some questions, trial questions that will rear its head or might be able to. There are possible questions that can come into our quiz tomorrow. So we can't prepare less. So we have to prepare adequately to face this particular quiz. So what we are going to do is that We are going to solve all these series of questions. Some of them we will skip them. All right, so let's begin with question 1. So if you have any question, you can put them in the comment section, and then I will be able to check and then look at it for you. All right, so let's move. Now with the question 1, it says if the line y is equal to 2x plus c is tangent to the circle x squared plus y squared equal to 5, what are the possible values of c? So in that case here, we want to find the possible values of c. So how do we go about this problem? First, we treat the equations given to us as simultaneous equations. That's, we are given y is equal to 2x plus c, and then we are given x squared plus y squared equals to 5. So this is our equation 1, and this is our equation 2. Now the next thing we do is that we now solve the two equations simultaneously. All right. Already the first one, the equation 1, y is already made the subject. So what do? We substitute that into equation 2, and then we'll be able to solve that. So substituting that in equation 2, we have x squared plus, so here y is here, so y, so we have 2x plus c, and then we are equal to 5 here. So this is what we have. We can simplify whatever we have here. And so if you are going to simplify, what are we going to have? We're going to have x squared plus 2x. Sorry, there's a square here, so we square. So we have a square here. So we have, so when we expand this square, what are we going to have? We're going to have 4x squared plus 4xc plus c squared equals to 5. Now we can, so now we can so now we can now have x squared plus 4x squared plus 4xc plus c squared equal to 5. Now, if I simplify it, I have 5x squared plus 4xc plus c squared equal to 5. If so, now what we have to note is that for a line to be tangent to the circle, the resulting quadratic equation must have exactly one real root, which means that the discriminant of the whole thing should be equal to 0. So we are saying that if for this line to be tangential to the circle, then the discriminant, that is b squared minus 4ac, should be equal to 0. Should be equal to 0. So in that case, if we compare this one to our equation, we'll have, so our b here is 4x or 4c, so 4c, and then So we have 4c squared minus 4. Our a here is what? 5. And then our c will be c squared minus this 5. That will be, so that will be plus c squared minus 5. Sorry. So here we have this one here. So we'll have 4 brackets 5 times our c squared plus minus 5, sorry, minus 5. And that should give us what? 0. And that should give us 0. Okay. So in that case, can we do some simplification? Yeah, we can do. So we have 16 c squared minus, now when we do our math here, we are going to have 20 multiplying c squared minus 5, and that should give us 0. So I have 16 c squared minus 20 c squared minus 100. So here it will be plus 100 equal to 0. And so if I do the math here, I'm going to have negative 4c squared plus 100 is equal to 0. Now if I do the math, I have c squared to be equal to 100 over 4. And that will be what? So we have 100 over 4 will give us 25. So c will be equal to plus or minus 5. So this is a simple question given to us, but our ability to think around what we have learned will be able to help us solve it. So in simple terms, we solve these two equations simultaneously, and after solving it simultaneously, we use the discriminant, that is b squared minus 4ac. Because if we are saying that the line is tangent to the circle, then the discriminant must be 0. So if it is 0, then we are having c equal to plus or minus 5. Alright, now let's move on to question 2. What is the length of the tangent drawn from the external point 7, 6? What is the length of the tangent drawn from the external point 7, 6 to the circle x squared plus y squared equal to 25? Okay, so one thing is that we have to be able to determine our center and then our radius from whatever is given to us. So the length of the tangent L drawn from the external point x1 and x2, x1, y1 to a circle centered at the origin x squared plus y squared is equal to r squared is given by the general formula. So we have a formula for that, and that is L is equal to square root of x1 squared plus y1 squared plus minus r squared. Minus r squared. Alright, so from our equation, we know x1, we know y1, and then we can also determine our r from the equation given to us. From here, we can see that our equation, already we know that if we have a circle equation like this, we have the x squared, y squared, and then the other part is the radius. So in that case, our L will be equal to the square root of our point, that is x1, which is 7 squared, plus our second point, which is 6 squared, minus our radius, which is 25. So please, here, we just have to be able to tell and know that, okay, this is the formula, and so if you use the formula, you are safe. So here, let's simplify, and if you simplify this one, you're going to have this one to be equal to square root of 49 plus 36 minus 25, and that will give us square root of 60. So our answer is square root of 60. All right. So please, these are some of the things that we can meet in our exam. But I don't think this one, basically it will come because when we were studying, we didn't look at the length of a tangent drawn from an external point. So these subtopics will not be there. So some of them, I might skip them because we know that it will not come. All right, question 3. It says find the coordinates of points where the circle intersects with the y-axis. We are to find the coordinates of the points where the circle x squared plus y squared minus 6x equal to 0 intersect with the y-axis. So how do we do that? We know that any point lying on the y-axis has an x-coordinate of 0. Any point that lies on the y-axis has an x-coordinate of 0. So it means that if you have this, if any point that lies on this one has an x-coordinate to be 0. So in that case, x is equal to 0. So we substitute this 0 into the equation given to us, and then we try to solve. So we do that, and we have 0 squared plus 5 squared minus 6 0 equal to 0, right? And so we will have y squared to be equal to 0, which means that when y is equal to 0, then that is where those are the coordinates where the circle intersects with the y-axis. So this implies that y is equal to 0. And so the answer is B, which is what? 0, 0. All right. Question 4. Which of the following of these lines is perpendicular to the line given to us? That is 3x plus 5y minus 8 equal to 0. So what you have to do is that here we don't particularly know the line that is going to give us the perpendicular. So we find the gradient of all the lines that we have, and then we solve. So we find the gradient of this one, and to find the gradient, we make sure that the y coordinate is so we just use the general form, which is y is equal to mx plus c, and in that case we'll be able to find our coordinates. So what do we do? From the first one, the A, option A, we have 3x plus 5y minus 11 equal to 0. In our case here, we can say 5y is equal to negative 3x plus 11, right? Then we divide 2 by 5, here by 5, here by 5. Then we have y to be equal to negative 3 on 5 x plus 11 on 5. So here our gradient is what? So for this one, m is equal to negative 3 on 5. Now the gradient of this one too is what? Negative 3 on 5. So if the gradient of this one is negative 3 on 5 and the gradient of this one is negative 2 on 5, and we know that if two lines are perpendicular, it means if you multiply their gradient m1 times m2, you are supposed to get negative 1. So in our case here, if we have negative 3 on 5 times negative 3 on 5, what are we having? We are having positive 9 on 25, which is not true in our case. So A cannot be our answer. Then we look at B. So for B, we are saying that 5x minus 3y minus 11 equal to 0. So in our case, what will be our gradient? Our gradient is going to be, so you take this one across and then we have y to be equal to 5 over 3x minus 11 on 3. So this is what we have. So the gradient is 5 on 3. So we have 5 on 3 multiplying 3 on 5, and that'll give us -1. So we all agree that whatever be the case, we are going to have -1. So our answer is B. So in our case, our answer is B. All right, question 5. So please, here, what is the takeaway? The takeaway is that if lines are perpendicular, their gradient always multiply to give us -1. And so in this case, we don't have a special way we can find this thing by just finding the gradient of each line and then comparing that to or multiplying that with the gradient of the line given to us. If it gives us -1, hallelujah, that is what we use or we choose as our answer. All right, so please take notes. Now question 5. Question 5, it says that find the equation of the perpendicular bisector AB where A and B are the coordinates, the point -4, 8, and then 0, -2. Now, if we talk about the perpendicular bisector, we mean that a particular line that is going to cut line AB into two equal parts at an angle of 90 degrees. So we have this line. So let's picture it as we have line AB, A and then B, and then A is, so let's say A is -4, 8, and then B is 0, -2. This is what we have. All right, so if we have AB and then we have another line meeting this line at an angle of 90 degrees, so this is the line we are talking about. So we want to find the equation of this particular line that is meeting AB. So how do we find the equation? We have to know one of the points and then also know the gradient of this particular line here. And then in that case, we can be able to find the equation of this particular line. So let me label it L1. So how do we find the one of the points of this line? As this line is a perpendicular bisector, that means that it meets this line AB at exactly the midpoint of AB. So it meets at M. So we can find the midpoint M. So M is giving us x1 plus x2 all over 2, and then y1 plus y2 all over 2. So in our case here, we can have the midpoint of AB to be, so midpoint of AB, and that will give us 0 minus 4 all over 2, and then 8 minus 2 all over 2, and that will give us -4 on 2, and then here will give us -6 on 2. So when I simplify this, I'm going to have -2, sorry, this one is not going to be negative, it's going to be +6. Alright, so bear with me. So we have, and then we have 3. So this is the midpoint, and so we've been able to find one of the points on this line. The next thing is that we need a gradient of this particular line, but we know that if to be able to find a gradient, since this line, the line we are talking about here, is perpendicular to AB, if we're able to find a gradient of AB, it will help us be able to find the gradient of the line we are talking about here. So what do? We find the gradient of AB. So gradient of AB, so the gradient of AB is giving us, so we have y2 minus y1 all over x2 minus x1. And so in our case here, we can have, what is our point? So we have y2 to be -2 minus 8 all over x2, which is 0, minus -4, which is +4. Then this one gives us -10 on 4, and that will give us -5 on 2. So this is our gradient. This is our gradient, negative 5 on 2. But we know that if it is perpendicular, then it means that if you multiply m times negative 5 on 2, you are supposed to get negative 1. And so if we do that, we are going to have m to be equal to 2 over 5 as the gradient of the perpendicular bisector, this one. So now we have our equation, we have our perpendicular bisector. So what do we do next? We just substitute everything into the general form, or the way we find our general equation, which is y minus y1 equal to mx, sorry, mx minus x1. But don't forget, this line has this point. So the point given to us is, we have this point, negative 2, 3. Please, under no circumstance should you go and take the point of A or the point of B in solving this problem. Alright, so we have y minus, our y1 here is 3, and then our x is going to be, so we have our m is 2 over 5, so we have 2 over 5, and then x minus x1, which is now minus 2, so plus 2. Now if you simplify everything, I'm going to have 5y minus 15 equals to, so let's simplify this. 2 times x will give us 2x, and then 2 times 4 will give us positive 4. Now if we rearrange it in such a way that we can find our answer here, then we have 2x, this one goes, then we have minus 5y, then if this one comes here, we have negative positive 15 plus 4, that will give us 19, so plus 19, and that will give us this. So 2x minus 5y plus 19 is our answer, and so the corresponding value is A. Alright, so that is that for question 6. Please, if you have any question, you can ask. You can ask in the live chat. If you have any questions, you can ask. If you have any question, you can ask. Okay, so let's move on to question 6. Question 6. So let's move on to question 6. All right, so in question 6, please, if I'm moving too fast, you let me know, so that in the comment section you can just input it there that I'm moving too fast or I'm moving too slow. Then I'll attend to you. All right, so let's move on to question 6. Now, in the question 6, it says that a circle x squared plus y squared plus 2 equal to 4, and then x minus 6 all squared plus y squared is equal to 16 relate to each other in which way? They relate with each other in which way? So first, you determine the center, and then the radius of these circles that has given to us. These are the two circles. So if you remember, one of the topics we did this thing. So we are supposed to look at how they relate with each other. In what way? In what way do they relate with each other? So let's move. So the first one is that you find the center and the radius. So to find the center and radius of x squared plus y squared equal to 4, what will be the center? If you compare it to the general form, our general form of the equation is x squared plus y squared plus 2jx plus 2fy plus c equal to 0. This is the general form. And then the center from the general form is given as negative j, negative f. And then our radius is given as, so r is given as square root of j squared plus f squared minus c. So this is what we have. So for the first equation, we can know that our c is going to be 0, 0. So it will be at the origin. And then the radius, our r is equal to square root of 0 squared plus 0 squared minus our c. In our case here, if we take this one across, we are going to have negative 4. So minus plus 4. And this is what we have. So our r will be equal to 2. Right. Then we do the same thing for the second circle, which is x minus 6 all squared plus y squared equal to 16. So what will be the center? So let's say this one is center 1 and then center 2. What will be the center of this one? What will be the center? So we'll have our center to be 6, 0. From here we can have our center to be 6, 0. Then plus. So this is our center, and then our radius will be what? root of our j is 6, so 6 squared. All right, so we'll have, okay, all right, so let's continue. Sorry for delaying you. I was attending to someone. All right, so let's move on. So from here, please, those who are not seeing this one, what we are saying is that if you want to find the center of this one, we can go by using what we have here. So let me go simple on those who are not seeing what we are seeing. All right. So the next one we have x minus 6 squared. So we can expand this one where we have x squared minus 12x plus 36, right? Then plus y squared equal to 6, right? This is what we have as our equation. Now, if you simplify this one and put it in the form x squared y squared plus 2jx plus 2fy plus c, we're going to have x squared plus y squared minus 12x. Now, when I take this one in, I'm going to have positive and negative 6. So I have plus 30 equal to 0. Now, how did we get our center? We are saying that our center, if you compare, it is negative j negative f. So in that case, we'll have 2j to be equal to negative 12, right? And that will give us j to be equal to negative 6. So j is negative 6. And then we don't have any f component. So this means that f is also 0. So our center will be c to be negative j, which is 6, and then 0 here. Then our radius r is giving us square root of negative j squared, and then this is what we have. So we have negative 6 squared plus our 0 squared minus our distance here, which is this one, that is 30. So we have minus 30. This is what we have. Minus 30. This is what we have. Alright, so in our question is supposed to be 16 or 6. So it's 16, sorry. So here is supposed to be. So if here is 16, and then we take this one across, we are going to have here to be 20. So this is supposed to be 20. Alright, so our C is 20. So minus 20 here, minus 20 here. So minus 20. And that will give us R to be equal to square root of 36 minus 20. And that will give us root of 16. And that will give R to be equal to 4. So now we have our radius, the two radii. Then we have our centers. Now you compare the distance between the centers and then to the sum of the radii. So if I have F R1 plus R2, what would the sum be? I'll have 2 plus 4, and that will give me 6. And then we now find the distance between the centers. That is the exact point at which the sum occurs. So that is our D. And so we can say that D is equal to R1 plus, so our distance, that is the two centers. So you have to be able to, so we are comparing the sum. So you compare the sum of the radii to the distance of the centers, between the centers. That is what you are supposed to do. So you sum the radii. This is what you're having. So let's find the distance between the centers. Now our center 1, C1, is 0, 0. And our center 2 is 6, 0. So how do we find that distance between them? We know that the distance between 2 points, we can use this one. That will be x1 minus x2, or x2 minus x1. So 6 minus 0 squared plus 0 minus 0 minus 0. So 0 minus 0 squared. And that will give us root of 36. And that will be equal to 6. So now, if we compare the distance between the centers and then the radii, and they are equal, then it means that the circle touch each other externally. If it is the other way around, it touches it what? Internally. So you compare. If the radii is less than the distance, or it is greater than the distance, so you look at that. So here we can say that since the distance is equal to the sum of the radii, we are saying that the circle touches each other externally. So the correct answer to question 6 is B. So they touch them externally. Now let's look at question 7 a little bit. I should be quicker here. What is the equation of the diameter of the circle x squared plus y squared minus 2x minus 4y equal to 0? So we are looking at the equation of the diameter. And if it is the diameter, then what are we talking about? We are talking about a line. So in other words, we are looking for the equation of a line that passes through the center. So now, how do we know the equation of the diameter? What you have to do is that you have to find the center, we find the center of the from the equation of the circle. So to find the center, we know that it is negative j, negative f. And in our case here, what is our j and what is our f? So we have 2j to be equal to negative 2, and our j will be equal to negative 1. And then our f is 2f is equal to negative 4, and our f is equal to negative 2. So in our case, our center is equal to negative, so negative 1. So in that case, you have j to be 1, and here you have 2. So our center is 1, 2. Now, it passes through the center, and then the center is 1, 2. So we have been able to find that one. Now we can calculate the slope of this particular line based on what we are given. So the diameter must pass through the origin and then the center. From here, we say that what is the equation of the diameter of a circle? X squared plus y squared minus 2x minus 4y. That passes through the origin. So one of the points on the circle passes through the origin. That is 0, 0. And so if we have these 2 points on the diameter, we can be able to find the gradient of that diameter. And so let's find the gradient of the diameter. That will be y2 minus y1 and then x2 minus x1. So in that case, our gradient m will be equal to y2, which is 2, minus y1, which is 0, all over 1 minus 0, and that will give us 2. So we have been able to find the gradient, and then we know that generally equation of a line is given as y minus y1 equal to mx minus x1. So we just use one of the points, and then that's our center, or we use the origin to find that. And so we can say y minus 0 equals 2 bracket x minus 0, and that will give us y to be equal to 2x. And so the correct answer to question 7 is y is equal to 2x. So you see, you might have the understanding that, oh, I can generate an equation or the equation if I'm given the diameter, but it's not always going to be that way. As in our question 7 is saying, if you have x squared plus a circle, and then we are asking you to generate the equation of the diameter from the circle. So that is how we can go about these things. Now the question 8, it says find the equation of the tangent to the circle x squared plus y squared equal to 25 at the point 3, negative 5. Alright, so the equation of the tangent to the circle at a specific point on the circle is given by a formula, and then we can have the formula to be x1 plus y1 equal to r squared. So some of the things is just the formula. So x1 plus y1 equal to r squared. Now at the point, they have given us the point x1, we have what? 3, and x2 we have negative 4. We substitute everything here, and then we're going to have 3x minus 4y equal to our radius, that is 25. And so the correct answer is B. Alright. Now question 9. Question 9. It says find the equation of the circle with endpoints of a diameter that. So here we have two main ways we can go about this. So for question 9, we have 2 ways we can go about it. That we should find the circle, the equation of the circle with the endpoints. So we are given A to be 3, 5, and then B to be 1, 1. So I'll go by using the perpendicular. So if I have this circle here, and then I have my diameter. Since that is what we are saying, that AB is a diameter. Now I have A to be 3, 5, and I have B to be 1, 1. If I draw a line, I consider any point P of X and Y on the circle, and that is perpendicular to point A and point B, then I can find the gradient of these lines, and then that will give us -1. So I can say that y minus y1 all over x minus x1 multiplying y minus y2 all over x minus x2 will give me -1 if they are perpendicular. So in that case, if this is my x1, y1, x2, y2, I'll just substitute it into this formula. So if I substitute, I'm going to have y minus my y1 is 5 all over x minus x1, which is 3, and then I have y minus y2 is 1, and then x minus x2 is 1. Good. So we have that to be equal to -1. Now we all know that if we are going to manipulate this thing, we can multiply through by x minus 1, x minus 1, minus 3, x minus 1 throughout, and then we cancel it out. So we will have something like y minus 5 multiplying y minus 1 to be equal to negative, then we have x minus 3, x minus 1. This is what we have. Now if I simplify whatever I have here, we have, so let's expand, we have y squared minus y minus 5y equals to negative. Now we expand this one to, we have x squared minus x minus 3x plus 3. This is what we have. I will take this across with a minus sign and it will change to plus. So whatever is here will maintain whatever it is. So you have y squared minus y. So if I simplify this, I have minus 6y. So if I take this one, I have plus x squared minus. So if I simplify this, I'm going to have 4x plus 3 equal to 0. Now we arrange it in a form of the general equation of a circle. So we have x squared plus y squared minus 4x minus 6y plus 3 equal to 0. And so our equation is supposed to be, alright, so here it's even given in the general form. It's given in the general form of the equation. So here you just need to find the center and then the radius of the circle, and that is all. So if I've been able to find this one, I can find the center, and then the center will be negative j, negative f. So here, if I find my j, I'm going to have j to be equal to -2, and then I have my f to be equal to -3. So our center C will be 2, 3. Then our radius r will be equal to square root of -2 squared plus -3 squared minus our c, which is 3. In that case, we have 4 plus 9 minus 3. 4 plus 9 minus 3. And that will give us 10. So we have our r to be square root of 10. Now, if we substitute everything into the general form, the standard form, which is x minus h squared plus y minus k squared equal to r squared. Then what do we have? We have x minus 2 squared plus y minus 3 equal to square root of 5. Alright, so we'll have this one squared, and that will be root of 10 squared. So we have x minus 2. Please wait. Okay, so there is a mistake somewhere here. When we're expanding our last term here, negative 5 times negative 1 will give us positive 5. So we have positive 5 already here. So if this one comes to add, we will have 8. So here is supposed to be minus 8. So 13 minus 8, and that will give us root 5. So that is where the mistake is coming from. That is where the mistake is coming from. And so if I have that, I'm going to have root 5 squared, and that is the same as 5. So the correct answer to this question is x minus 2 squared plus y minus 3 squared equal to 5. So which of them corresponds to our answer? And then the answer will be A. Alright. Now question 10. Question 10 says find the equation of the circle that passes through the 3 points. So we have 3 points. We have given 3 points. 0, 0, and then we have 6, 0, and then we have 0, 8. So this is what we have. And then we are being asked to find the equation of a circle that passes through these points. So how do we intend to find the equation? Alright, so let me give you a clue and then I'll ask you to solve it and then give me your answer in the comments. So first, you assume the equation of a circle, the general equation of a circle, which we know that it is x squared plus y squared plus 2jx plus 2fy plus c equal to 0. So this is the general form of the equation. So first, you substitute these values in here. So let me do that one and then you see. Then you do the same thing for this one and then this one. After that, you give me your answer. So we have, so if, for the first one, that is 0.00. If I substitute, anywhere I see x, I'll put 0. If anywhere I see y, I'll put 0. So I have 0 squared plus 0 squared plus 2 brackets 2j 0 plus 2f 0 plus c equal to 0. So in that case, everything goes to 0 and we have c to be equal to 0. So this is my equation 1. Better still, I'll find my value for c. Then I'll do the same thing for 6, 0. So let's do that. So I have 6 squared plus 0 squared plus 2j6 plus 2f0 plus c equal to 0. In this case, this one goes to 0, and then we have, so this one is 36. I will take it across and I have 12j, that is this one, plus c equals to negative 36. But we know c already, so we can put c in here, and then we have 12j is equal to negative 36. We divide here by 12, here by 12, then we have j to be equal to negative 4, or negative 3. So negative 3. Now the last point is 0, 8. So 0, 8. So wherever we see j, x, we put 0. Wherever we see y, we put 8. So we'll have, so we'll have 6 squared. We'll have here 0 squared plus 8 squared plus 2j0 plus 2f8 plus c is equal to 0. Right. Now, if I simplify this, I'm going to have 64. Then this one will give me 0. This one will give me 16f plus c is equal to negative 64. Right. So if I divide through by whatever I have, I'm going to have 16 because c is 0. F to be equal to negative 64. And now f will be equal to negative 64 on 16. And that will give us 4. So now we have f, and then we have g. So we substitute everything into the general form, which is x squared plus y squared plus 2jx. So here in our case, we have 2 negative 3x plus 2f. Our f is negative 4, sorry. So negative 4y plus our c, which is 0, equals to 0. Then we simplify everything, and then we have x squared plus y squared minus 6x minus 8y equal to 0. So this is what we have for question 10. And so the correct answer is A. The correct answer is A. Okay. So, okay, so everybody, I want everyone to solve question 11. A circle contains 3 points. What is the center of this circle? So everybody, try your hands on this. Try your hands. Try your hands. Try your hands on it. Let's see. Everybody, try your hands on it. Try your hands. Try your hands on it. and then put your answer in the comment section. So a clue is a circle passing through 3 points. So find the equation, and then you'll be able to use that, or find J, F, and then C, and then that is all. You are gone. So if you're able to find J and F, that becomes the center. So let's be quick, 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 quick. 1 minute. 1 minute. Okay, so wisdom is saying that the answer is 4, 2. Isaac Sapon, F is 5, which F is 4. We want the whole point, the whole center. So the points, you give me all the points. You give me all the points. Okay, so wisdom is saying that the answer is 4, 2. Isaac Sapon, F is 5, which F is 4. We want the whole point, the whole center. So the points, give me all the points. Okay, so have you been able to find your center? So you didn't hear. Okay, so I said evaluate question 16 for me. Let me see. So everybody try your hands on it. Question 16. Question 16. Let's try our hands on question 16. Question 16. Let's try our hands on question 16. Okay, so Tony is saying that is 4. Tony is saying is 4. So what are you also saying? Tony is saying is 4. So what are you also saying? Okay, so Tony, you are saying is 4, right? So for this one, if I substitute 2 in directly, I'm going to have 0 over 0, which is what? Indeterminate, right? But we know this one. If we have x squared minus 4, right? We have x squared minus 4, and I want to break it. I will have this one to be equal to what? Or if I want to rewrite this one, if I have x squared minus 4, it is the same as writing 2 minus x and then 2 minus x. You get it? So this is what we have. Now we can bring the negative out, and then we use that one to cancel we use that one in the denominator. So let's factor this one out. So we want to rewrite the whole equation so that it looks like x minus 2, and in that case we can be able to cancel whatever we have. So this is what we have: 2 minus x and then 2 minus x. So if I rewrite this one again, I'm going to have negative out, right? Then I have x plus 2, right? And I have x minus 2. This is what we will have, all over x minus 2. So this will be the limit as x approaches 2. Now we can cancel this one out, and I will have negative x plus 2, and that will give us negative 4. So our answer is supposed to be negative 4, not 4. Not 4. So please, you see, these are some of the technicalities that comes with the questions that we are given. If you don't take time, you might know your way around it, but you will not get the answer. Okay, so let's move on to the 17. So evaluate x to the power 4 minus 16 equal to, so this one too, we can just use the same approach. So please evaluate that for me. Evaluate that for me. Quick. Question 17. Question 17. Question 17. Evaluate that for me. Okay, so Emmanuel Kwashi, you are saying that won't it is it not supposed to be 2 minus x and then 2 plus x? Please look at what we have there. Look at what we have there clearly. It is the x squared that is negated. So if we are going to go by that, that is 2 minus x and then 2 plus x. You can evaluate whatever we have here, and let's see if you will get that. So we have 2 minus x, so 2 plus x. That's what you are saying. All right, so let's simplify this one again, and then we'll have 2 plus times 2, that will give us 4. Then this one times this one will give us negative 2, so positive 2. All right, and then we have 2 times x, that will give us positive 2. So this one 2x and minus 2x minus x squared. All right. So Emmanuel, okay, wisdom 32. 32 is the answer. 32 is the answer. All right. So it's true. 2 minus, so we have plus that. But okay. I didn't what I did here. So you say, so it is supposed to be 2 minus x and then 2 plus x. Please take note. If they draw our attention to the mistake, we correct it and we continue. Understood? Alright, so here too the same thing. We have to apply these principles. So we have x to the power 4 minus 16, which we can rewrite this one as x squared minus. So we can rewrite that one as x squared minus 4, and then what? S squared plus 4. Right? Now we can rewrite this one as difference of 2 squared. That will be x minus 4 and then x plus 4. Then we have x squared plus 4 all over. Sorry, here is supposed to be 2. We have x minus 2. So x minus 2 can take care of x minus 2. Then now we substitute the value 2 inside. So we have 2 plus 2, that will give you 4. Then 4 times 16. So we have 2 plus 2, that will give us 4. And then 4 squared, 2 squared, that will give us 4. 4 plus 4, that will give us 8. And then 8 times 4, that will give us 32. So our answer is supposed to be 32. Please, those who are not seeing, you can see now. Alright. Now let's move on to question 18. Question 18. We are learning together. Question 18 says that given the piecewise function, we are given f of x to be equal to, and then that is what we have here on the piecewise function. Evaluate the following limits. That is, limit as f of x approaches one from the positive. So from the positive, which of the functions are you going to use? From the positive, which of the functions are you going to use? So looking at the two functions, you choose the functions that will be able to you will be able to know if it is from the positive or from the negative. So from the positive is a greater than, A is negative, all these values, the values here will be less than -1. That we can have -2, -3, -1, and so on. This one will be greater than, so it will be from the positive. This is from the positive. So we are going to use this particular thing to evaluate the limit. So in that case, we have limit as x approaches 1 from the positive, x squared plus 2. So please, if it is a piecewise function, check from the positive, that is, it is greater than a particular threshold, so it will be greater, to be moving. And then if it is less than, then that means that it is going into the negative. So you choose the one that you think the limit is approaching from the positive. So in here, if I substitute in my 1, what do I have? I'm going to have 3 as my answer. So please, here our answer is B. Now evaluate the following limit as x approaches 3 from the negative. So for the question 19, I want you to solve and give me your answer. Question 19, solve and give me the answer. Question 19. Okay, so here, what is our value? I'm not seeing anybody giving me an answer. So please give me your answers. Okay, so initial is saying it's negative infinity. It's saying it's negative infinity. All right, so let's see. So from here, we can't actually, if we put in values from the negatives, we are, as we know that for limits, it is not at the point or the number at the point that we are interested in, but actually the behavior of the function as it approaches that particular number. So we are going to look at it from the negative. So we can take values like 2.9, 2.99, 2.99999. That is values that are approaching 3 from the negative. So you can put values like that there. And then you know that if you put these values in, as the more you put them, as large this particular function becomes. The more you put numbers closer to 3 into this function, the more it becomes big. But how big does it become? It becomes big in the negative direction. So in that case, we have our C to be our answer. So please, this one, when you get the question, what you have to determine is that, okay, from the negative, so 3 from the negative, that is from this side. So what are the numbers closer to 3? Don't just choose any number. Numbers that are very close to 3, like 2.9, 2.99, 2.999. Now you put this one into the calculator, and when you put it in the calculator, what happens? You see that you'll be getting large values that are negated. And so in that case, since the values are large and very large, then it means that this particular function approaches the negative infinity. Now question 20, let's move question 20. So this one too, I want to answer. Question 20. So James, you now know that it is not positive infinity, and also Owusu, therefore, please, you also know that it's not 0. Now let's look at the next question, question 20. Question 20. Okay. Inusa is saying it's 1. Oh. You agree with Inusa? Okay. So here we can evaluate the limit as it approaches from the right. Definitely, some of us will go and choose undefined, and if you choose undefined, you are dead. You are dead. So we know that this one can be written as, is the same as, if you have square root of a, is the same as absolute of a, right? So in that case, I can rewrite this one. So I know that the square root of x squared is equal to absolute of x. So I have limits as x approaches 0 from the right, absolute of x over x, and then I'll put it in a piecewise function where I'll now have negative x on x as x is less than 0, and then x on x as x is greater than 0. Now from the positive, we know that this one will give us negative 1 and then 1. So in that case, we'll choose this one, and that will be the answer. Please, these are some of the questions. You will meet them and then you might flop. Now let's be vigilant in whatever we do. Alright, question 21. Evaluate the following limit. Limit as x approaches 0 tan 2x all over sine 5x. and 2x all over sine 5x. So how do we go about this? We know that if we evaluate the limit of a sine function, limit as x approaches 0 of sine x on x, we are going to get 1, right? So from here, we can say that tan 2x is the same as writing sine 2x all over cos 2x. Do you agree? I know that definitely all of you agree. So in that case, what happens to our equation here? We will have 2x, sorry, we will have sine 2x over cos 2x divided by, or can we say times, sine 1 over. So let me write it this way so that you all know how it looks like. Okay, so we have this divided by our sine 5x. If you take the reciprocal, then we now have sine 2x all over cos 2x multiplying what? Sine 5x. Do you agree? Okay, so we also know that, as I said earlier on, we said that if we have a limit as x approaches 0 of a sine function, let's say sine k x over x is also equal to k. Sine kx over x is equal to k. So what we can do is that we can divide through by sine 5x, and so if I divide through by sine 5x, I'm going to have sine 2x all over x. So I divide through by x. So this is what we have. We are dividing through everything by x. We have sine 2x, right, over x all over sine 5x all over x, right, times our 1 over cos 2x. Now what are we going to get for this one? We know that if we evaluate any limit like this, our answer is whatever is here. So k. So what will be the answer here? 2. And what will be the answer here? 5 times 1 over cos 2x. Okay, now we can evaluate our limit at x equal to 0. So if we evaluate the limit as x is equal to 0, x approaches 0, then we now have 2 over 5 times 1 on 1, and that will give us 2 over 5 as our answer. So the answer is A. Alright, so if there's any question, you can ask all your questions. The questions you want to ask, you can ask all your questions. Ask your question, don't keep it. Now question 22, I want you to try your hands on it. Question 22, try your hands on question 22. try and answer on question 22. So probably I want to do 30. Then if time permits me, maybe tomorrow morning I'll do the other 30. If time doesn't permit, you go and write. Please, when you are writing, just open your eyes. Some of the questions, they just demand a little bit of thinking, just small thinking, and then that's all. And then try as much as possible to be able to synchronize whatever you've learned earlier to whatever you are learning now. And then if the question is given to you, try to see what principle do they want me to apply here. If you know the principle you want you to apply, you are good to go. So question 22. Question 22, I'm waiting. We know that if you do direct substitution, it will not go, right? Here, if I do direct substitution, I put 0 here, 0 here, it will not work. I'm going to get 1 over 0. 0 over 0, which is indeterminate, right? So here, 0 over 0 is indeterminate. So what best we can do is that we either use the conjugate or we use Hopital's rule, right? So if you want to use the Hopital rule, you just differentiate whatever we have here. The top, you differentiate whatever is there. So if I differentiate this one, I'm going to have, if I differentiate cos, I'm going to have negative sign. So I'll have sine x, sorry, all right. So let's use the conjugate first, and after that we use the Hopital's rule. All right. So here I can have, so we are giving limits as x approaches 0 of 1 minus cos x all over x squared. This is what we are given. So we take this and we multiply that by the conjugate. So we are just going to evaluate this one. We have 1 minus cos x all over x squared times 1 plus cos x all over 1 plus cos x. Right. Now if I do the multiplication, I'm going to have 1 minus cos squared x all over x squared, and then multiplying this one. So we have 1 plus cos x, right? But we know from trigonometry that 1 minus cos square x is the same as sine square x all over x squared 1 plus cos x. So what we can do is that here we have an idea that sine x over x, the limit of sine x over x as x approaches 0 is 1. So same idea, we split this one into 2. So we have limit as x approaches 0 of sine x over x all squared, right, times 1 over 1 plus cos x. Now here, this one is giving us 1. So 1 squared. Then we substitute our 0 here. And then we'll have 1 times 1 over 1 plus 1. And that will give us 1 over 2. So our answer is 1 over 2. Our answer is 1 over 2. Please, if you have any question, let me know. Let me know. Let me know. If you have any question, let me know. All right. Now, question 20. So our answer here is supposed to be half, which is C. Now, question 23. This question, if you look at the face, maybe it will come, maybe it will not come. So we just have to go around it. Now we can rewrite everything that is given to us. Wait, so let me write it here. We are given that we evaluate limit as x approaches 0, x cosec 3x all over cos 2x. So we can rewrite this. We can rewrite cosec 3x as 1 over sine 3x because it's just the inverse of that. Right. Now let's substitute everything back into our equation. And then if we substitute everything back, we're going to have x. So we have limits as x approaches 0 all over sine 3x multiplying cos 2x. Right. So this is what we have. We can split whatever we have here. We can split whatever we have here. And we will have limits as x approaches 0, x over sine 3x multiplying 1 over cos 2x. Right. Now, you see, this principle is very serious. It's very, very nice. And then if you apply, you always, if you have sine kx over x, the answer is whatever is here. So that will be k. So if I have something like this, and right now it has turned, where I have limits as x approaches 0, x over sine kx, then it will be the reciprocal of that. And so that our answer will be 1 over k. So in that case, let's apply that principle here. So if I'm going to apply that principle here, what would this one be? This one will be limits as x approaches 0 of 1 over 3 times 1 over cos 2x. Now if I substitute 0 in, I'm going to have this whole thing going to 1, and then that will give me 1 over 3. And so our answer to this question is 1 over 3. So question 23 is 1 over 3. Now question 24. 24. We are given sine x as x approaches pi, x over pi, x minus pi. What is our answer? So would you like to try this one? If you want to try it, you can try it out. All right. If you want to try, you can try it out. No question. All right. Okay. So let's see how we can go about this question. So we are given sine x over x minus pi, right? As the limit approaches x as the limit approaches pi. Now what we can do is that we can use substitution here. So we let u be equal to x minus pi. But if you make x the subject here, we are going to have x to be equal to u plus pi, right? And then we substitute that here into this equation. So I'll have limits as x approaches pi. So if we do that, then our limit changes. Our limit changes. So the question you have to ask yourself is that as s approaches pi, what happens to u? Then u will approach what? Will approach 0. We all agree. So u approaching 0, and then we'll have sine x minus pi. Sorry, here is x. So here is x. So it's supposed to be u plus pi. So we have u plus pi. So we have u plus pi all over u, right? Now we apply the trigonometric principle that if we have sine u plus pi, we can write it as negative sine u. That is when we use the sum, the compound angles. You have sine u all over what? All over u. And so this will give us negative 1. And so if we evaluate everything, we're going to have this one to be equal to negative 1. And so that is C. Alright. This question is straightforward. Evaluate the limits. And so if we have sine x over x, already you know the answer, which is also what? Is now if I substitute these values in pi in, I'm going to have sine pi over pi. And so sine pi over pi, what do we have? So sine pi is 0 over pi, and that will give us 0. So 25 is straightforward. Now question 26. Evaluates x cos x over x plus 3. Here you can just substitute in your 0 and then we are gone. So let's substitute in our 0. So if I substitute in my 0, I'm going to have 0 over the whole thing. That will give me 0 over 3. And that will give me 0. So the answer is what? Is A. Now question 27. We have this. Evaluate the following limits. X squared sine 1 over x. So here, what you have to do is that if you substitute in the 0, the whole equation breaks, or the whole function breaks. So what you have to do, you apply the sandwich theorem, which we know that sine 1 over x will lie between 1 and negative what? Negative 1. Now we want it to look like this one, so we multiply through by x squared. So we have negative x squared less than sine 1 over x. So I'm multiplying through by x squared. So in that case, I'll have x squared. Now I evaluate this limit as x approaches 0 of x squared. And what are we having? 0. Then we do the same thing for this one. Limit as x approaches 0 of x squared. This is negative x and this is x squared. So we have 0, 0. And so since they are all giving me 0, the answer is what? 0. So it's C. Question 28. 28. If we substitute everything inside straight forward, you see that this one is 0. So 0 multiply everything, giving us 0. And everything that will happen here, we don't care because to give us 0. So it's B. 29. Evaluate the limits we have. So we know that still this one we are going to apply sandwich theory. We know that cos 1 over x squared will lie between what? Will lie between negative 1 and 1. So if that be the case, we can multiply through by absolute value of x. And then if I multiply through by absolute value of x, I'm going to have negative absolute of x less than or equal to absolute of x cos 1 over x squared less than absolute value of x. Now if I evaluate this absolute value as x approaches 0, I'm going to get 0 here and then 0 here. And so the answer is what? 0. The last question I'll solve here is this one. Now question 30 says that we should evaluate the limits. So the best idea is that always you try to substitute everything inside first before you try or think of any other method. So if I substitute everything inside, I'm going to have 1 over 2. And this is it. Alright, thank you for joining this live. If any of you think you want me to continue the next 30 questions, there are 60 questions plus some theory questions. If you want us to continue, you can let me know. If I get about 5 people texting me to tell me that okay, I should continue, then I will do that. I'll do that maybe probably in the morning so that we go and write. If you don't understand anything, please let me know. Don't keep it. Don't keep it. Don't keep it. Tomorrow, I wish you the best of luck. Bye bye.